I'm supposed to be talking about the dynamic distributed tracing for the edge, but we have a great talk before about the observability and the tracing, and lots of the things were covered before. We change a little bit. It will be a very quick introduction to the workload characteristic using tracing. Okay, we can skip that. First, we need to understand what is the cloud. And the cloud, actually, what is just like a bunch of the big servers, which can characterize by the same amount of the network, storage, and the CPU. There are good attributes, but on the other side, cloud deployments are used to be, everything needs to be deployed in the same place and far away from the users. That's the big disadvantage for the cloud deployments. It's that your deployment will get a big latency, and especially for the application that rely on the latency, we can say just like a CDN application or the network cache, we would like to deploy those applications to the edge. The edge, you can characterize that it's just the servers who are living very close to your home location or to your company, and they need to communicate sometimes with the cloud, and also they have lower capacities. And also another thing for the edge, which is the one of the use case, that the edge servers needs to be autonomy. I mean, they need to have autonomy. That if they will lose the link, they need to still run the workload, and they need to be able to live without any other connections. As a typical edge application, we can say just like this network functions, service chains, also analytics on the edge, route infrastructure, or as we probably know, that's the very popular workload which is deployed by the Netflix is the cache or the CDN, which is living close to your houses. Also, another thing which is big disadvantage of the edge, that if you're trying to deploy the servers across the multiple edge servers, you will see just like that the capacity of those servers is very different. They tend to be big, just like a very small server, or just like nearly the home appliances where your workload needs to be. For the sample of this very short talk, I was using the distributed router, which need to communicate along the edge and also need to communicate with the cloud infrastructure. And our application was of course built in Go, and as you can see, have multiple concurrent jobs because it needs to be procket and forward the packets. And that was actually deployed using Kubernetes, was living on the 2 cars on the normal cloud, and they was on the same NUMA node to allow. Of course, our application contains instrumentation. In this case, that is, we are using the OpenCensus framework, OpenZipkin for traces. We are sending the traces to the Zipkin. OpenCensus was also responsible to send the custom stats like application KPI or to have possibility to measure SLA of the service. Everything was working fine on the cloud, but when we come to the deployment to the edge, we seen just like because the servers, so they are quite smaller, we seen there's like a time spent of the most of the router functions was much bigger, especially when we were pushing a lot of the traffic. We were looking at the number of concurrent functions, and they were, we seen just like they were pretty high. Okay, then of course we try to look at the telemetry. For the telemetry, we are using Prometheus, and we are trying to add another layer. We are mostly using the PMU metrics, which is like a performance metrics for the CPU. And we try to look, okay, what is actually, what is happening with the service? Why the same application, we're living on the edge, it's behaving completely different. But why is that 3%? Because of course we need to know the root cause. Why is that happened? And another thing is just we are not able to do that offline because the edge server tends to be far away, and we try to get this amount of the data of the telemetry. We have a big bottleneck here. And a few years ago, the IBM also published a very good paper, and he said that the 90% of data which we are collecting the telemetry is useless. And only 10% is actually the people are looking in it. Then the telemetry, it's a big overhead. Not always. There was a really good use method, which is done by the Brett Gardner to the sometimes, when at this moment we see just like a use method is not reliable. Then you can see just like of his talk, which is really good. You can see just like a utilization is wrong, because actually if you see 100% of utilization, then you see that that's actually the server is not really overloaded. Then we choose that completely different method, which is a top-down method, which we are looking at the front-end bound, back-end bound, and retrying. When we see just like a returning is good, when the CPU can process your workload, and we also, when you're looking at your workload from the top, you can see just like bottlenecks on the network card, cache, on the core utilization. Thanks to that, telemetry is not a big overhead, because actually we are looking at the two values. Is it front-end bound, when you see just like it's a problem with the network, or it's a back-end bound when you have a problem with the value. When we look at the analysis, and we see just like, okay, it's highly back-end bound. Then we looking at the top-down method. Then we looking at the, okay, it's L3 bound. Then what we can do with this data, we then look at actually it's working. And what we can do, we can scale down vertically.
There's always
and
one.
Migrate to the CPU.
Thank you so much.